Hello everyone, welcome to this online session. My name is Vaishnavi Vijaykumar. I am studying in B.Sc. second year in Adarsh College. Today I am representing in front of you theorem on the real sequence. In real sequence, theorem is on monotonic sequence. Before moving on the theorem, I want to tell you what is a sequence and what is a monotonic sequence. And sequence is a function whose domain is the set n of a natural numbers and range set of real numbers is called as real sequence. The monotonic sequence, it is an increasing sequence or decreasing sequence. When we say monotonic sequence is increasing if Sn less than equal to Sn plus 1 for all n, and monotonic sequence is decreasing if Sn plus 1 less than equal to Sn for all n. After that, we are moving on the theorem. The above theorem says that for the convergence of monotonic sequence is that it is bounded. In the above theorem, we have two conditions. First is necessary condition and another one is sufficient condition. In necessary condition, we know that every convergent sequence is bounded. When the sequence is bounded, the sequence is bounded above or bounded below is called bounded sequence. And the another one is sufficient condition. Sufficient condition is about consideration. A bounded sequence Sn. We seen what is a bounded sequence in starting of the session. Sequence is bounded above or bounded below is called bounded sequence. Let it is monotonic increasing sequence. We seen in the starting of the session what is monotonic increasing sequence if Sn less than equal to Sn plus 1 for all n is called monotonic increasing sequence. Suppose S denotes its range set, then S is bounded. It has a supremum, say M as supremum, then for epsilon greater than 0. M minus epsilon is not an upper bound, therefore there exists Sm such that M minus epsilon less than Sn, but the sequence is monotonic increasing. We seen in the starting of the session what is monotonic increasing sequence. Therefore, M minus epsilon less than Sn for all n greater than equal to M. Again, M is supremum. Sn less than equal to n less than M plus epsilon for all n. Therefore, M minus epsilon less than Sn less than M plus epsilon for all n greater than equal to M. That is mod of Sm minus M less than epsilon for all n greater than equal to M. Hence, we prove that the sequence is convergent and limit Sn is equal to M. Hence, we prove the theorem. Thank you for watching this video.